Okay, so this is a set of notes on how do we generate power. Now, almost every time that we talk about generation of power, we're talking about electrical power. So electrical power is usually conceived of as moving some sort of an electron along a wire. Okay, so ultimately electrical power is a type of kinetic energy where we're moving a subatomic particle through a conductor. And in the end, the key here is that you have to find ways to make that happen. Now, almost every type of power that we generate involves using a metal rod that is going to be surrounded by like copper coils. And if we turn that metal rod, the electrons in these copper coils start to move, and we can push that out into a wire, and we get some sort of electric current. Now, this type of apparatus with the metal rod and the copper coils is what we call a generator, or sometimes the term is used dynamo. Okay, so this is the core idea that tends to be used in almost all electric power generation. There's a couple of small exceptions to this. One we're going to see in a little bit, which is going to be not wind, wave power. And usually when you do wave power, you have the coils and you have the metal rod going through it exactly like you do with the dynamo, but instead of spinning the metal rod like you do with a generator, you make it go up and down, which leads to the electric current. So this is all powered by some sort of electromagnetic reality. The other one that's going to be a little bit different is going to be um, solar, where solar uses a special thing called a photovoltaic cell, where we're taking light energy and we're using that light energy to move an electron. So this is a little bit different of a game. The photovoltaic cell changes light energy into um, kinetic energy of electrons, which is what we call electrical energy. Okay, so we have a broad list of these ways of producing electrical power. Probably the most common way that we do it is by using fossil fuels. Fossil fuels are things like coal, natural gas, diesel, sometimes biofuels. In each of these, we're burning something. So we use the fuel, we create a burn. Usually we heat water, using that burn to create water vapor. We condense that water vapor and we push it against some sort of turbine, which is like a kind of like the water vapor hits this and causes this to spin. That turbine is connected to the generator that we just described, right? And this produces electric current. Okay, so fossil fuels is a matter of heating and then taking water and turning a turbine and going there. So if we get into nuclear power generation, basically it's the exact same apparatus. We're going to heat H2O, we're going to use that to turn a turbine. The turbine is going to turn some sort of generator. The turbine. The turbine turns a generator. The generator moves an electron, right? So we have water vapor here. Nuclear is very similar to this, except for instead of burning a fossil fuel, we take these really big atoms, right? So we get really big atoms here with big electron shells going around them. And these things are radioactive, right? And because they're so big and they're so radioactive, they want to split. They want to become smaller, more stable atoms. So the atom splits in two, but when that happens, we find huge release of energy in the form of heat. So when you split an atom, you get a lot of heat. That heat is again going to heat water. The water is going to turn into water vapor that we condense. The water vapor turns a turbine. In turn, that turbine is also turning a generator, and it creates a mobile electron, right? So the electrons start to flow down some sort of wire. Okay, so that's two, right? Now, hydropower works in a very similar way. Let's take a look at how that works. So to do hydropower generation, generally speaking, we have a body of water that's sitting at one altitude, and then we have a dam. Okay, so this is my dam, and this is water. So this might be like a lake or something like that. And then the dam lets the water out, and you have water down here. So what we're going to do is we're going to open and we're going to put a channel in this dam. And in there, right there, we're going to get a turbine. Okay, so we're actually going to use the gravity here. So if I open a gate here and let the water flow through, the water turns the turbine and falls down here. But while it's turning that turbine is also hooked to a generator, like we said before, and that generator moves electrons. And those electrons move a wire, and now we have electricity. So this is how they do this with hydro. It's basically a gravity operation, and usually it's a pretty natural thing because the rainfall fills the lake, and then you open the dam and let it go down into a lower body of water. The gravity causing the water to fall through the dam allows us to turn the turbine. So that's pretty much how hydropower kind of works. Geothermal is another option. Geothermal reality is that if you go down into the ground, you can hit kind of a warmer space. So as you start digging far enough, it's going to start getting warmer. The Earth's core, or at least mantle, is warm. So as you start getting closer to that, things start getting warmer. So what we do is we pass some sort of like water into this space so that while it's down there, the water warms, right? This H2O is getting pumped down here, and then it gets pumped up to a heat exchanger. And then it looks like a radiator, right? So the heat exchanger causes radiant heat to come up from the warm water. And then we cycle the water back down, it gets warmer, it cools as we exchange the heat, but the heat is released. That heat ultimately heats H2O, turns it into vapor. That vapor, as we've seen before, pushes a turbine. That turbine is hooked to a generator, right? And the generator will push out an electron and we get electricity. So this is like a pretty sophisticated operation here. It's using the natural temperature of the Earth to be able to heat water. The idea there is that we use that water to turn turbine, turbine turns generator makes electricity. So this works really well when we have we don't have to dig far to get to heat. So places that are relatively close to sea level, islands, things like this can do a lot of geothermal kind of power. Another pretty common one is wind, and this is something that's becoming more common. So you build like one of these big wind turbines with big, huge blades like this. in there, that wind turbine, so this thing is already going to spin, right? So that wind turbine is hooked to a generator, and that generator again makes an electron and moves it along with power. So this is a pretty simple apparatus to create electricity, but you need to have like big, huge rotor blades to make that work. So this is what some people mistakenly refer to as windmills. They're actually wind turbines, but that's a way to create electricity using the power of the wind. We've got some folks that are also using things like ocean currents. So here you've got kind of like an arm that's attached to something here, and this arm is attached to a metal rod. That metal rod is in and around coils, and this thing is on the surface of the ocean. So this whole apparatus is going to be attached to some sort of like buoy or boat or something like this. And this thing is going up and down. So as it passes over and under waves, it's going to go up, it's going to go down, it's going to cause this post to move up and down. That post moving up and down causes a flow of electrons through these coils and gives us what is, again, electricity. So this is a way to use the motion of the waves of the ocean to actually produce an electric current. And this is something that's kind of emerging still, but it's not one that we hear a lot about, but definitely something that is functional and will work. Solar is actually kind of energy harnessing, right? So we've already got energy coming in from the sun. The sun is in the form of light. We have a device called a photovoltaic cell, right? So that photovoltaic cell absorbs the light and basically transfer that light absorption into electron motion, and this is how we get solar. So this is like one of the few methods that doesn't have a generator per se with a coil attached to it. This is a direct harnessing of one form of energy and transferring it directly into another using an apparatus called a photovoltaic cell. Now I want to talk about a couple of ways that we can talk about power that are not necessarily electrical. Okay, there's about 4 of them that we can easily identify that are non-electrical power sources. You have stuff like steam. Okay, so like old locomotives worked on this idea that you would compress instead of releasing the water vapor, you would compress the water vapor, right, until it got to a certain poundage, right, or a certain number of newtons, right? So once I have those newtons, I can release some of that steam pressure, and that will actually move something, right? So now I have newtons moving over meters with respect to time, so that's power, right? So I can actually, boil something, and as things get warmer, the pressure increases, which means my newtons are going up. If I release some of that steam, I can use that to drive something and move it. I do that over time, so that's an example of powering. Like steam locomotives and early steam engines worked on this principle. We've seen historically that we've used water, and a lot of that is a matter of bringing water over like a water wheel. This is like a precursor to the generator idea, right? So this turns the water wheel, and in turn, that turning mechanism could be geared, belts and things like this, turn other things, and using gearing, you can actually perform tasks like milling or drilling or sawing using a water power wheel. No electricity involved, just the water itself is creating the force. But again, this is a gravitational fall. Water's moving from a higher level to a lower level. So it's much like hydroelectricity, but except there's no generator in the process. Historically, we've also used wind power, right? So before we had wind turbines to create electricity, we actually had windmills, Don Quixote and the windmill and all this, and you'd spin the windmill, and it would turn something here, And down here, that thing that's turning originally would do things like mill grain. It can also turn a drill. It can turn a saw. It can do everything you could do with like the water power. But again, there's no electricity here. The windmill itself, so the force of the blades turning is actually turning other mechanical parts in order to create kinetics, in order to make work. And then that work over time means that we've produced power. Finally, another one that comes up is compressed air. Okay, air, sometimes called pneumatics, so compressed, make that a little neater, air, it's sometimes called pneumatics. So in this case, you take air, you insert it into some sort of container that can handle the pressure, you put more and more and more in there, and then you release it. So it's going to come out with newtons worth of pressure times meters of distance, and that's going to do that over time. So that's a form of power. Okay, in actuality, like your mechanic at who works on your car, this actually could produce a lot of power if this thing is considered is kept pressurized. So your mechanic actually has wrenches that hook up to air hoses, and those wrenches turn on compressed air power. You hear when you go to a mechanic shop, you hear like a when they're turning, or a kind of sound. Usually, those power wrenches are actually air powered. Now, the trick to this though is how do you keep the air compressed? And usually, that's either done with an electric pump, or sometimes you can use a manual pump to compress air. We're actually going to do something with this later in the year. Our last project in the class is going to be a tennis ball launcher, where we're going to compress air using a bicycle pump, so it's a manual pump. And then we're going to release it, and it's going to cause a force, which ultimately will get us the idea of motion of a tennis ball because it's pushing off of compressed air. So there you go. Whole bunch of ways of creating electrical energy. I think the list includes fossil fuel burning, nuclear power, hydropower, geothermal, wind power, wave power, and solar power. And then we have a couple of ways to make power that's non-electrical, like steam compression, water, turning a wheel, wind, like windmills, old school, and pneumatics and compressed air. So the whole idea of converting one energy to another in order to do work is the idea of empowering things. And this has been a little bit longer video, but there's a lot of ways that we can actually generate power.